Okay, so today I'm going to be showing you another video, and today I've got here a 3x3 piston door. I've made several designs before. This is my most recent one, fastest and best looking. So, this is my area where I'm currently trying out redstone. So, several versions, different things. You can see some other frames of it. I'll go over those later. Other things I was working on. I guess I'll show off not just this. There's some other redstone contraptions in there that I could show off. This is Bedrock Edition Minecraft. So these only work in Bedrock Edition, and I'm guessing they would probably fail horribly in Java. I also know that these pistons would probably not work because some of those mechanics I recently learned this is not possible. But you may not know what this is, and I didn't either. So I'll talk about that later. But for now, you can just look at my main 3x3. So that last delay thing I couldn't fix without ruining the staircase in the front. You technically don't need a staircase in the back. This is actually, so technically I didn't need this back. So I could probably fit more stuff in back here. It's just much harder because where a lot of the stuff is gonna be where the lever is, and that's the front usually. Another thing is that I can't get a button to work. Is much harder to get like a button pressed to either turn it on or turn it off. Something like that's much harder, so I'm unable to get a button to work right now. I might be able to get that in a later design, but it's probably going to be bulkier. There's a really decent amount of redstone in there, so my only method's too big, which would use water and boats and things, which is also very weird when I guess it uses entities too, so it's not the best way. I prefer my contraptions not to have entities unless they're entirely entity related, like mob farms. So this is my 3x3, really nice and fast. Has a nice spiral action. It's the best spiral I can create, and it also keeps down some of the slowness because it's not possible to get in 3x3 piston doors as fast as in Java because pistons are slower in Bedrock. I'm guessing the reason is for lag, but I in general prefer them faster. I'd also prefer them to spit out their blocks, which would make the button system much easier, but they don't. And the main reason is actually piston slowness, because in Java Edition, when pistons are powered by one tick pulse, they finish extending early and start retracting, but the block takes some time to place itself, I'm guessing. So basically what happens is that it drops its block. It still can pick it up with a one tick pulse. So on one fire it picks up the block, another it spits it out. And that's what's used to create button presses like that. So it's a bit more complex than that, and some basic circuits are decently big still, but it just makes the entire circuit much easier, but not non-existent. So but I can still use this, and this is still a fast door, and I've tried to design it so that you don't really need it to be too smaller, because you probably would want it to be smaller. Those big walls. I'm expecting like 3x3 doors like this. You'd only put that in really big darts. The main thing is that there's a lot of redstone in the corners. My older design was even larger than this, so this is much tinier and much faster and more beautiful too. My old design was even horrible, and it had honey blocks next to the walls, so you could only use like what is it, like obsidian and stuff, or you would have to move the wall even farther, which would make it look even more worse. So there's not much else in this design really. So I would probably show off how to do this. Because I'm not the best at it, but this is my basic wireframe design of it. And then this is basically the exact same thing, just with wireframe as well as the circuits shown. So I'm going to go over each of the circuits. The smallest is the yellow one, which deals entirely with this one. With this piston, which is supposed to store the block. Simply, we have 7 ticks over here, running into the main circuit, which I'll talk about next. Grid circuit here. So this is connected to the lever. So then we have there's really two different parts of the red circuit. We have this part of the red circuit, which runs down and basically it runs across. It runs over these two pistons, which have observers on their faces, facing into those. Basically, what this does is when you flip the lever on the bottom piston fires fast. As when you flip the lever off, the top piston fires fast. So that's what that thing does, and then it runs down through here and into one tick repeater here that goes into blue circuit. I'll talk about later. And then over here we have two ticks. This is basically this redstone automatically power these pistons. If you're wondering if you haven't seen redstone before, redstone redirects the pistons. So that's pretty useful. And then over here we have two tick redstone repeater that runs into this block, which means that this piston activates 2 ticks later than the rest of these, which makes it. I'm trying to get a spiral motion. I can't get these two one separated, but without moving the lever, making it bulkier, which I do not want to do. So I could get the rest to be separate though. And then up here we go 2 ticks. So 2 ticks later than this one fire after this. So 2 ticks after this one fires, this one does, or extends or retracts, whatever. But then there's a special thing in Bedrock Edition, and I can show you, is that torches can tell whether the piston they're on is powered or not. This is a feature exclusive to torches and exclusive to Bedrock Edition. So basically that's one interesting feature I've used a lot here to help get the signal to transfer down. It looks very weird, and I just recently I learned about this on Minecraft Wiki, which is no longer considered official. I'm pretty sure. At least that's what it said in the main thing. So, but it still provides good info, and this was pretty surprising, even though it didn't have some inaccuracies on some other Minecraft Bedrock bits, because there's not as much of a Minecraft Bedrock community. I'm pretty sure. At least I haven't noticed it as much. So basically, we have this torch crunched. So basically, what happens is the torch figures it out. It takes 1 tick, and then it powers this torch, which also takes 1 tick. So it's 2 ticks from this piston to power this one, and then it does the same for this piston, and then it does the same for this piston. And it's a bit more bulky than my older mechanism, but it looks much better. And then let's go to the blue circuit next. So the main thing here is that we have, again, when earlier the red circuit, it ran into this repeater that ran into this block. What this does is that it basically checks when the circuit's on, it's not supposed to be doing the double extender, so it pushes the observer out of the way, which is doing the double extender part, which is a circuit that I came up with, but that's really interesting. It cannot be used for a default double piston extender in Bedrock. It could in Java, but not in Bedrock. Basically what we have here is we have this, and it runs into a block, runs into redstone, and we have glass, and we have piston this here, and then redstone like this. Yes, and then if we take a lever and power this, just watch what happens. I discovered this system, and it's the fastest way to do a double piston extender because of how Bedrock works. I'm guessing pistons extensions aren't calculated precisely, or something. It's probably something to do with moving around between block entities and stuff. So basically, it causes the So basically the pistons are inaccurate. But the best way to do it is having a 1 tick pulse is detecting when the piston actually gets there. So for example, this circuit, it doesn't it does this, which is not that interesting, but it does something. So you can do something like that. That's what I used in that part with a bit edited, because basically in the second part, when you want to spit out the block, you don't want it to take it back. So what we do is remove it so we can move the block out of the way when we're closing up. So we have to change the circuit slightly because we can't put the redstone on it. So what it looks like is, since it takes a different amount of time for each, so basically what happens is the piston's first powered by this, and it's also powered by this line later. which causes it so that basically it's gonna take a 1 tick for it to extend, well 6 ticks it takes after it depowered for it to retract. 1 tick after powered to extend, 6 ticks to retract. That's why we need this circuit over here. That's needed for the green part of the circuit that's making sure that extends for the right amount of time. And then meanwhile over here, this is the main part I'd shown over here. Here we have a slight adjustment to work out here. The main thing is there's no way I could actually power that piston with a 1-tick thing without expanding it a lot, because this observer moves here. So if there was a block here, it would be pushed over here. So basically what you'd have to do to make it would be run redstone around like this. That's way bulkier, and that meant the slight delay at the beginning. So basically this block here is to prevent this redstone from connecting to this one. They're supposed to be separate parts, and then this block is, well, it's not technically for this exact purpose. Another thing is that this block does not have to be glass. It does not have to be a non-solid. Glass is used for non-solid so that the redstone can actually run up. It doesn't have to be glass. It could be just a normal block. I don't know why I put glass there when I've been designing it. But then it goes straight into the last circuit, or the green one. So what it does is it takes 4 ticks. An observer detects, so it goes to 5 ticks. Next 5, and then it goes. So basically, after 8 ticks, this piston extends, which causes this circuit to activate during the opening, because this is only during the opening. This also activates during the closing. Closing actually, it activates during both of them, but since this is off during the closing, this one just pushes out another block instead of actually taking in the middle block, because this is responsible for taking in the middle block. So at 8 ticks it extends, and then this circuit activates, making it pull down the middle block, and then it takes longer to retract to prevent the piston staying here. It takes longer to retract, which would be that's 2 ticks longer. So this basically it stays on about 3 ticks, which then it retracts and pulls the block in. And that's the slight delay you see here. And then it pulls the block in, and that completes the opening. Opening is the most complex part. Or closing is the easiest bit, but what I've been doing is commonly just annoying bit as you're trying to fit it in. So, this part does the first parts of both the opening and closing. When it turns on, it fires out the first block. When it turns off, it pulls in the first block. And this circuit does not need a separate timings for opening and closing because they're the same. So that, I think, should describe everything. You can look over through the video to look at how to build this. You can just click a quick another tour about it. And then I think it's just one other contraption that I want to show you. Is one that I developed. That one I was trying to do a 4-piston extender. Failed to get it to work. But here's the one I'm talking about. I'm using a solar panel here just to make it so that I can, I don't know, I didn't have a lever. So basically, this is basically a 3-piston extender. And for a double design, the base design that I use is something like this. Java's design works because the pistons are faster. It's more like 2 ticks, 4 ticks, and then something like that. It's also more compact, but this is what happens. This is what happens in Bedrock Edition. And it's also inconsistent because of the problems with piston mechanics. So this is the design, the fastest one that I've come up with that works. If you're wondering, this is technically how fast a Java, nearly how fast Java's things are. and it's really random. So this is the, if you tried to take it to 2 ticks, there's things like that. So I've discovered the minimum is pretty much 3 ticks. I think I tried this. I can't remember whether it worked. No. Yeah. So this is the minimum. And if you want it faster, you could technically, this would be only if you want really fast contraptions. Actually, it would be more something like, actually, you could probably do something like this, where, would that actually work? Or test. I don't know. Well, technically, you'd need something like this. It would look more like this. So this is a faster design, but it's not great. So this is my 3x1. It's definitely not made in it's definitely not super compact. It's really hard to get it this compact, but this is the fastest design. And yeah, there's a lot of piston action going on here. One thing about it is that I have 2 different circuits. Circuits work. One thing about it is that at least in some of the later ones, I can have 2. Because basically, in certain parts of the contraption, I'm pretty sure 2 different pistons can actually be used at the same time, or pretty close together either way. So this is the fastest one, and it still has a problem in that it's really hard to power this thing and if you were wanting to keep it at least, because basically for this to work, there would have to be a block there. Here in Java Edition, you'd use quasi connectivity, but you'd have to have a block in this location. You have to be able to power it, which makes like larger piston doors using triples really hard. So this is basically the this is the fastest triple piston extender I have developed, and it's not my first. My first one was actually when I'd actually first developed the second one. I know when I first developed it, my original development design looked something like this. Later I discovered I didn't need the 4 ticks; it could just be 3. So this was my earliest development design. Yeah, it's a bit slow, and there's not much I can do about it. So I later developed a better one, but not much I can do to improve it unless pistons are slow. Pistons are sped up so they work faster, which I would like to happen, but I don't know if I expect it. There's a lot of it. I think one thing I've noticed is a lot of attention focused on Java Redstone because there's a large community. Bedrock Redstone doesn't seem to be as much. Well, at least I can show off the design here. So the main thing we have is we have a redstone line running. So basically, it instantly powers both these pistons at the same time. So basically, if there was a piston here, it would instantly power. But so basically, what would happen is basically, so this one extends immediately thanks to this. So it extends immediately, but there's also a little bit of a circuit behind here, that basically does the there's a little circuit behind here that basically makes sure that this piston stays extended long enough so that everything can be retracted back. So we have that's 5 ticks for this piston. So basically it's 0 to 5 ticks powering for this piston. There is for this spot here it is basically 0. It would be basically, I guess it would be, I think that is it's basically just 8 ticks. No, yeah, it would be 8 ticks. So 8 ticks for this spot. This spot's actually a bit varied because we have the observer technique used here to make the piston fire really well. Well, I use an observer in this part. So technically, so that would activate right after, and it also activates on 3 ticks here. On this one is 6 ticks for this one. So this is my fastest design, and I don't think I can get much faster unless they change bedrock redstone. I don't know what I was doing here. It's just a weird play around design. And then we have some other things around here. This was originally a world where I was making a computer thing, but it never came to be. But I was struggling a lot, so I ended up going out. Then I went back in to do some redstone. So I think that's it for today. So bye, see you in the next video.